Hi, everybody. I hope you're doing well. These are the first set of slides that I'm posting with an audio narration. Um, it's an interesting format, I think. It took me a while to get comfortable, or I should say, get more comfortable talking to my computer like it's people. But I think I'm nearly there. Um, I apologize for any kind of low sound quality here. I'm just working off my laptop. I did order one of those nice fancy microphones, but I think a lot of people under quarantine might be getting into podcasting or other professors with a little bit more budget than me jumped on it earlier. So I did order one, but um, the delivery time pushed back a little bit. Should expect it sometime in April. Anyway, getting to the substance here, I'll be talking about kind of broad overview how electricity is generated in Massachusetts, and also kind of as an aside, some statistics about home heating. Um, It'll kind of provide some background, some context for what we're going to get into during the last couple months of this course. A broad overview of kind of the facets or important features to know about electricity generation in Massachusetts. It's dominated by natural gas. This hasn't always been the case, but it's not an incredibly recent development either. It's kind of been the kind of the source of lion's share of electricity generation and home heating in Massachusetts for a few decades. But that doesn't mean that there aren't other important, potentially increasingly important trends in how energy is generated here. Um, some of these trends have been driven by legal mechanisms, and I'll touch upon a couple of them today. These have been in effect for the last decade or two, and they kind of continue to escalate, um, causing more and more uh, raising the threshold for renewable generation in the energy mix. Also, there's been a very recent closing of a nuclear power plant in Massachusetts. So this kind of creates a little bit of a vacuum in that energy that had been generated as recently as last year is no longer in the mix and kind of points to questions about what's going to make that up. The first figure I'll show shows through time the percentage of total electric energy by resource type here. It has these statistics for 5 years: 2000, 2005, 2010, 2015, and 2018. Seven categories here: natural gas in light blue, nuclear in orange, net imports in yellow. This is energy that's not generated in the state. Most of that is hydropower generated up in Quebec, Canada. Green here is renewables, kind of the darker blue hydropower, um, dark gray coal, light gray oil, kind of liquid petroleum products. So if you look at kind of the more recent time intervals, there isn't that much difference. I mean, the biggest change between 2010 and 2015, maybe between 2010 and 2018, is increasing imports of hydropower from Quebec. But if we look at all of the time intervals together, some of the big trends do become apparent. So early on in this millennium, there was kind of a more than doubling of natural gas energy generating electricity in the state. It does increase between 2005 and 2010, but that increase is noticeably smaller as a percent of the initial value as between 2000 and 2005. So natural gas shot up in those 5 years, and since 2005 has basically been generating 35–40% of all electric energy. Nuclear has been surprisingly constant at around 25%, 27% of the electric energy in Massachusetts. Um, Talked about imported hydro. I think local hydro has been pretty constant. Renewable energy, it looks fairly constant through the first decade here. It then it's increasing, small in percent terms, 6 to 9. But if you look at 6% versus 9%, that's an increase of about 50%. So we'll take a little bit closer look at that as we go forward. Now, the other big change is this decline in coal and oil. So kind of carbon intensive energy sources from comprising, what's that, 34% in year 2000 to 2% in the most recent years. So it's not really used much at all now. Moving forward to a kind of a different way to present some of these same values. It's here we're looking at in-state generation. So all bars, they don't include that imported hydro. It's got a few more categories here in kind of the lovely color scheme that they chose, the Union of Concerned Scientists. They're not concerned about aesthetics as much, I guess, as climate change. There we can see natural gas kind of growing from a smaller portion in 2001 up to a reasonably large portion 2006, kind of continuing there. Some years where it's even about 50–60% of the electricity mix. Remember, this is not kind of 100% of what we saw in the last figure. It's maybe 85%, say 90%. Kind of disaggregated here are biomass burning, wind, and solar. These three categories, wind, solar, biomass, would have been grouped as renewables in the last figure. You can see them right up at the top here. Most of the renewable energy was biomass burning. A lot of this is kind of waste material, taking the methane that rises up out of that, using it for electricity generation. Till 2011, when we can start to see a little crack of purple, growing a little bit the purple and also the yellow, the solar energy generation by 2014. So even that growth of renewables, solar and wind comprise just a small portion of that, but it's the portion that's really growing here in recent years. And then finally, we see petroleum liquids up here, dropping down to just about nothing in 2010, and coal somewhat monotonically decreasing, and we know from the prior chart it decreases even further. One interesting figure I did see, and I include here, is kind of how is oil, not coal really, used in the present or contemporary energy mix in Massachusetts. And it's really only used during times of extreme cold. So this figure here shows the average fuel mix for most of December 2017, but then for a 2-week period after Christmas, basically, shows the average fuel mix here. And natural gas portion declines from 46 to 24%. Nuclear declines a little bit, maybe more power generated, or more electricity generated during this time too. Renewables, fairly constant. Hydro, fairly constant. Coal, an increasing portion, 2% to 6%. But then oil jumps up from 0.3% to 27%. So oil is really only used during times of extreme cold. And it's useful in this way when kind of energy demand jumps up because of the way it's stored, the kind of infrastructure there. So natural gas, kind of the what's carrying the load of electricity generation, mostly comes via pipeline from New York, Ohio, and Pennsylvania. And it's got the kind of delivery system is this, you might have heard of just in time. Storage systems are not very, well, they don't have very much capacity. There's no kind of underground storage as there is in some of the areas where the geology allows for it. And so liquid oil and the kind of existing storage facilities for that allows that resource to be tapped in times of need. So moving on to some of the legal um, institutions, I guess, that have driven some of this change. The first is called the Regional Greenhouse Gas Initiative. So this is something that 9 states in the northeast of the U.S. began discussing in, I believe, 2002. Finally established this initiative in 2009. It's a cap and trade system on energy generators and the carbon that they can emit. So kind of you can see in this figure, Virginia, New Jersey, and I believe now Pennsylvania are in the process of joining this market. And it really comes down to those states' governors' elections. Kind of Republicans had been the governors, got voted out. So these caps decline every year, but states like Massachusetts, the actual total electricity generation energy use has also declined pretty steadily year to year due to increasing efficiency. So in order to kind of maintain reasonably functional energy markets under these caps, um, basically been something that has been accomplished through efficiency gains and the transition from oil, coal to natural gas. So, somewhat better. Though, as we'll see, it's not totally clear um, if all of the emissions that are truly generated in the process of natural gas extraction are accounted for. It is not primarily this region, this RGGI, has not primarily been driving the growth of renewables. Instead, there's kind of a basket of standards. So this is at the state level in Massachusetts, where they've implemented things called Renewable Portfolio Standard, and that's been in effect for the last almost 20 years now. And also more recently, Alternative Energy Standard, Clean Energy Standard. So these require a certain percentage of electricity to have been generated from renewable sources. And it started off very low, and it increases by 1 or now by 2% every year, so that by 2050 we meet some kind of good sounding threshold, 50%, 80%, something like that. So nuclear power had been considered okay because it's carbon neutral here. Um, but kind of the source of a lot of the nuclear energy that was going into the Massachusetts grid was coming from the Pilgrim nuclear plant in Plymouth, Massachusetts. And that began decommissioning in summer 2019, so no longer um, able to draw power from there. As part of these standards, there have also been solar carve-outs. So these are saying, okay, if we look at renewables, we're looking at biomass, wind, solar, and here nuclear, hydro, but also specifically some amount of that required percentage needs to come from solar. And I believe these went into effect in 2010, 2012, been a couple of them. And that has been somewhat reflected in here, the growth of solar capacity. So this chart shows for each year, 2010 to 2019, the number or the capacity of new solar installations, and kind of breaks it down by type. You can see a little, but just a little in 2010, 2011, increasing sharply in 2012, continuing decent sized growth in 2013, 2014, really ramping up 2016, 2017, but then also settling down. So this is still increasing capacity and doing so at a sizable rate. But clearly the growth is no longer accelerating with the rate of change here. So questions going forward, things that we're going to be discussing in more detail in the next few weeks. Cost and infrastructure lock-in. So kind of the continued utility of oil is by virtue of existing infrastructure for storage that allows it to be tapped during cold spell in the winter. So as the energy landscape in Massachusetts continues to evolve, the question is really about the continued presence of gas in that mix. It has, over past decades, allowed the state to claim, and the electricity generators in the state, the utilities, to claim growth in less carbon intensive sources, so declines in the amount of emissions linked to electricity generation. But as kind of costs for renewables go down, as understanding of the impacts and kind of contemporary state of climate change develop, um, kind of the questions around the reliance on gas take on a bit more prominence in discussion, specifically with the decommissioning of the Pilgrim nuclear plant. And so this doesn't eliminate nuclear as a source of electricity generation for consumers in Massachusetts, because there are still operational plants pretty close to the border in New Hampshire and Connecticut. But those plants face the same high costs of continued operation as did Pilgrim. And I believe the Connecticut plant recently demanded substantial state subsidies to continue. So these two plants continue to supply about 15 to 20% of Massachusetts electricity generation capacity, but that leaves a gap of about 5 to 10% with the closing of Pilgrim, and they're at risk of being decommissioned with relatively little lead time going forward. Third questions continue. Third question relates to the continued growth of renewables here. So solar, we see kind of a still an increase in installed capacity, but a decreasing rate of that in very recent years. Wind power. So wind power is a source that kind of the state had set pretty ambitious goals for capacity in wind power, but that never seemed to materialize. So we'll take a look at kind of an iconic case of that, of a project that didn't come to be, as well as talking about kind of, I don't know, revisions to expectations around that source of energy, and how, when, where that might compete, or that might come to be. And then finally, the question of what kind of conflicts arise over energy generation in Massachusetts. So these can be linked to the legal landscape, the kind of the physical land landscape, and also the infrastructure and environmental externalities, social externalities linked with different sources of energy generation. So think about the nature of those conflicts, kind of how have they arisen, but also how might they be resolved going forward.